Three particles A, B and C, each of mass m, are placed in that order in a straight line on a smooth horizontal table. The particle A is given a velocity u such that it collides directly with the particle B. After colliding with the particle A, the particle B moves and collides directly with the particle C. Coefficients of restitution between A and B and C is E. Find the velocity of B after the first collision. Write down the velocity of C after its collision with B. Three particles, these particles A, particle B and particle C. Particle A is given a velocity u, therefore the motion u. After that, then it collides with C, the velocity u, collide with B after velocity W and B, then this collide with C, W naught and B naught. Let the velocity of A and B after first collision are W and B. Here. W and B after first collision. When first collision occurs between A and B, we use I is equal delta mv. During the collision, I balance each other. Therefore, resultant I is equal 0. Delta mv. Final velocity m into w plus m into v minus before collision m into u. M is cancelled, therefore W plus B is equal U. This is equation number 1. Newton's law of restitution. Difference of velocity after collision is equal minus E times difference of velocity before collision. Difference of velocity after collision W minus B is equal minus E times before collision. Before collision, difference of velocity U minus this one 0, U minus 0. Therefore, W minus B is equal minus EU. This is equation number 2. 1 minus 2. W cancel, plus B minus B. Therefore, 2V is equal U minus EU. U plus EU. Therefore, V is equal half into 1 plus EU. Is half into 1 plus E into U. Find the velocity of B after the first collision. After the first collision, velocity of B, that is B, is equal half into 1 plus E into U. Last part, write down the velocity of C after its collision with B. Therefore, now the collision with C move with velocity V. Velocity of C is equal 0 after collision W naught V naught. Let the velocity of B and C after second collisions are W naught and V naught. So what is the V naught? V naught after the collision. Using the previous part, before collision U, velocity U, after collision half into 1 plus E into U. Therefore, here at equation 3, when replace U by V, V naught will be kept. Therefore, V naught is equal half 1 plus E into V. Like here. Here also moved with U after collision half into 1 plus E into U. Here moved with V after collision half 1 plus E into V. Is the V naught. Half into 1 plus E, for this B, we can put this one. Half 1 plus E into U. Therefore, this is half 1/4 1 plus E into 1 plus V, 1 plus E all things squared into U. This is the velocity of C after its collision with V.